Okay, hello everyone. Welcome to the session How Technology is Shaping Geopolitics. This online conference is organized by Goethe Institute Indonesian Center for Digital Society and Engaged Media. My name is Yearry Setianto and I will be your moderator for today. I'm a lecturer in Communication Science at Universitas Multimedia Nusantara Indonesia, and I'm focusing on critical data studies. In the next hour, we will listen to and discuss with our speaker, Wiebke Denkena, about technology and geopolitics. Emerging technologies such as AI, robotics, 5G are increasingly used to influence and geopolitics. As leading powers to compete to become global leaders, how will the geopolitical map be redrawn? How will it transform global power relations? If you have questions during the session, you are also welcome to type your question on the Q&A menu below. And we will have a discussion after the presentation from Wiebke. Now I'm going to introduce you to our speakers for today. Wiebke Denkena, she is a project manager for technology and geopolitics at Stiftung Neue Verantwortung, or SNV, an independent tech policy think tank based in Berlin. Wiebke, the time is yours.
Thank you very much for the kind introduction, and thank you very much to the organizers of this conference for inviting me. So I was invited, I will share my screen. I was invited today to say a few words about how AI is shaping geopolitics, and since these are very big topics, I had to narrow down quite a bit to fit in a lot of content into a 20-minute presentation. So I decided to focus my presentation on the question how the global competition for data, compute, software, and talent, these are the four main ingredients of any AI system that we see today, how this competition shapes geopolitical outcomes. But before I start, I will say a few words about Stiftung Neue Verantwortung, or short SNV. Stiftung Neue Verantwortung is a non-profit, non-partisan and independent think tank based in Berlin. And at SNV, different project groups engage with different subject areas that are all at the intersection of technological change and society. And the goal of our work is always to inform current policy discussions. So we look at current policy discussions and see where they are lacking, where there are maybe gaps, and then we try to provide additional background analyses, empirical evidence, critical perspectives in order to better inform the current discussions. And ultimately, our goal is, of course, to help reach better policy outcomes. SNV is a charitable organization by German law. This is also important to know. So in my presentation, I will first try and define what I mean when I use the term AI. So I will try and give you, I will attempt to give you a definition. This is of course not easy, but this will help to get us all on the same page. Then the main part of my presentation will focus on the four key ingredients that you need to build an AI system today. These are data, software, computing power, and talent. And as we will see, this is where the geopolitical competition already starts with AI. So geopolitical competition doesn't only happen when it comes to different AI applications, but it already starts at the level of these key inputs. Then we will have a short conclusion and outlook, and hopefully a nice discussion afterwards where we can dig a bit deeper. So what is artificial intelligence? When talking about artificial intelligence, I refer to what is often called weak AI or narrow AI. These are AI systems that can handle a singular task, or at least a very limited task. And this is the current state of research. These terms weak AI and narrow AI are often used in opposition to strong AI, or you may have also heard the term artificial general intelligence, or AGI. Or these terms connote the idea that we will at some point in the future reach AI systems with human level intelligence, or even AI super intelligence that surpasses human intelligence. But I want to make sure that it is clear that in this presentation, I don't talk about these distant scenarios, but I stay with weak AI and narrow AI, so the AI systems that we have today, where the current state of research is, and that already affect many people's lives on a day-to-day basis. So when thinking about AI as a field of research, it is important to acknowledge that it isn't one community or one big field of research, but it is composed of different subfields. For example, there's knowledge representation, computer vision, machine learning, natural language processing, and others. And all these subfields have different origins, different approaches, and different communities. In my presentation, I will focus on a specific technique, namely deep learning, that emerged out of the A subfield of machine learning. Deep learning is using neural network technology and using neural networks to train systems on large amounts of data in order to reach systems that can recognize patterns in data and then generate outputs based on these patterns they recognized. And deep learning, the techniques that fall under this term, have spurred significant progress since they had their breakthrough moment in 2012. So 2012 was really the year when deep learning received a lot of attention because a deep learning system won an important image recognition competition. So deep learning since then has spurred significant progress in different AI subfields. So for example, also in computer vision or natural language processing, where it has led to advanced, sophisticated applications, also commercial applications for facial recognition and language generation. So what I wanted to say with this slide, or what I want you to keep in mind, is that I will focus on deep learning, but there are other subfields in AI, other approaches that also exist. But many of the public acclaim and the commercial breakthroughs in the last years have been due to deep learning. So broken down, in order to simplify things a lot, all deep learning systems basically start with a very large training data set. So you could, for example, imagine a data set of images of written digits and then associated labels that tell us what digit is actually written on these images. If we set up a neural network, this purple box, with specific parameters, we can use such a training data set to train the neural network. For example, if we feed into the model an image of the number 5, the model will generate an output, for example, a 6. And since we have a labeled data set, we know that this is not the correct output. And by comparing the actual output and the desired output, we can set up a sort of feedback mechanism to improve the neural network. So we can improve the internal parameters of the network, and then it will it will get better if we do this with a lot of pairs of images and labels. And eventually we will hopefully reach a system that can recognize written digits, but it's also important to know that there's always an error rate. So it's never 100% accurate. So what I just described is the training of a neural network. It means optimizing a neural network based on a specific data set. And what I just described is supervised learning. So this happens when you use labeled data. There are also approaches where you use unlabeled data sets. This would be unsupervised learning. This works a bit differently. And I don't have time to go into that right now. Once you have trained a deep learning model, you can use it for inference. This means running the trained model to generate an output. And this is what happens, for example, if you have a commercial AI system. For example, if you write a character with your finger on the screen of your phone and you have some neural network implemented in some kind of app, then a trained model would be applied so that you receive that your phone is able to tell you which number you just wrote with your finger. So now I come to the second part of my presentation, focusing on the key AI ingredients you need to build a cutting-edge deep learning system today and to deploy it at scale. And this is, as I will show you, where the geopolitical competition already starts. So you need four main ingredients to build any cutting-edge system today. These are data, compute, software, and talent. And I will spend a couple of minutes about each of these in order to highlight why there's already a lot of geopolitical competition when it comes to these. So first of all, I actually need to minimize this window because I can't see the entire slide. So now it's better. So the first ingredient is data. Large and high quality data sets are really important to build deep learning models. Without large data sets, you simply won't get very far. But there are some differences. In some areas, data can be a huge competitive advantage. So for example, think about Meta, which controls the social networks Facebook, WhatsApp, and Instagram, and therefore has amassed over the years huge amounts of user data, specifically about people's social ties, so the social networks between people. And considering this kind of data, Meta really has a competitive advantage, whereas Google, for example, has a lot of information about people's searching habits, or Amazon about people's purchasing behavior. In these areas, data is really competitive because not everyone has it. In other areas, however, data is less competitive. You may have heard about these companies which build AI models based on data that is basically publicly available on the internet. For example, the US company OpenAI trained a large language model using data that is published by Common Crawl, which is a non-profit organization that crawls the internet on a regular basis and makes the data it collects publicly available. And GPT-3 was trained using this data. Also, we see an increase in open data. So more and more actors in our societies, be it economic actors, but also scientific. I think there are also some approaches, some attempts in civil society towards this, share data more openly. So this is, we see a kind of culture of data sharing emerging. And there's also a lot of research on synthetic data. So there's quite a lot research going into the generation of data, of artificial data, so to speak. So you can automatically generate data, which you can then use to train a deep learning system, for example. So overall, governments play an important role in defining the rules and standards for data collection and exchange and use. So they set the rules, what kind of data collection is allowed, and thereby can incentivize some forms of data collection and use and regulate and limit others. I think a good example to show or to highlight the role governments play in this context is facial recognition in China. Whereas in Europe, political decision makers are somewhat hesitant when it comes to facial recognition, even though it's not doesn't mean we don't have it in Europe. There are also many law enforcement agencies who employ these systems. The discourse is more skeptical around this. Whereas in China, the government has a mission to implement these kind of technologies on a large scale. This means that many law enforcement agencies, many police authorities buy these systems and from Chinese big tech companies and deploy them on a large scale. And this means also that these Chinese big tech companies get access to more and more data, so to more and more footage of images with Chinese faces. And this is the reason, so this governmental push is one of the reasons why Chinese companies are really, really strong and competitive in the field of facial recognition. The second key ingredient I would like to talk about is compute. So computing power is immensely important if you want to build a cutting-edge deep learning model today and to deploy it at scale. This is mainly, this has happened in recent years because researchers observed that larger models, so larger neural networks, lead to more sophisticated outputs. So, for example, language models have grown bigger and bigger, and researchers have observed that the bigger these models are, the more sophisticated their outputs are. So they generate, for example, more human-like and more nuanced language. But bigger models need more computing power to train on a given data set because they have many more parameters and many more calculations need to happen if you want to train such a model. So today we have reached a situation where training large models really requires supercomputing capacity. So you can't just do it in your garage, you can't just do it using your normal laptop, but you really need access to a supercomputer. And even if you have access to such a machine, where obviously there are not a lot of supercomputers around, even if you have access, it is still very expensive to train a big model in terms of energy use. Estimates for some of the latest milestone models go into the millions of dollars. On this chart, you can see how the compute requirements for deep learning models have risen exponentially over the years. Note that this is a logarithmic scale, so what seems like linear growth here is actually exponential growth that has even accelerated in recent years, which adapt deep learning era and large scale era on this chart. So the rising compute requirements lead to really, I find, interesting but also worrying power dynamics on industry level and on state level. On the one side, we see an increasing dependence on the cloud offerings of big tech companies who have these massive supercomputers in their data centers, who equip these supercomputers with custom-made AI chips. So Google, for example, has developed its own AI chip called the Tensor Processing Unit, and this is part of Google Cloud and also only available through Google Cloud. Also, these big tech companies have come up over the years with very interesting ways of hardware provision. So, for example, you might know Google Colab, which is basically a website you can visit and write some code, and then the code is automatically executed on Google's powerful machines, and you don't even need to pay. So these are all ways to attract people to the big tech cloud ecosystems. Second, there's also an increasing dependence on the cutting edge AI chips, which are predominantly designed by US companies like NVIDIA or AMD. And these chips are really needed if you want to build a supercomputer, especially those chips that are able to be connected to, that you can connect to large clusters. And the US is attempting to slow down Chinese progress in AI, especially military AI, via the exploitation of choke points in a semiconductor value chain. Recently, the US imposed export controls on high-end AI chips from companies like NVIDIA or AMD, and these can no longer be exported to China. The third ingredient is AI software frameworks. AI software frameworks play a really important infrastructure role in the AI ecosystem because they make it easier to train and run machine learning models. Basically, when you use such a software framework, it means that you don't need to build everything from scratch, but you can use some of the pre-built functions that these frameworks contain and that makes things a lot easier. Also, they simplify running code on large clusters of specialized hardware, which isn't really easy to do. These are some of the AI software frameworks that have been published since 2015. Notably, all of these are open source frameworks, but they have all come out of the environments of big tech corporations, first in the US, but lately also in China. The most dominant frameworks right now are still TensorFlow and PyTorch, although it is important to note that there's also a lot of dynamic in this space. When it comes to the geopolitical implications of these software frameworks, I think that prestige should not be underestimated. So these software frameworks are open source. That means that no central entity can control them or limit their spread. But I think for an AI company, it's still good to have such a framework because it shows that you're doing cutting edge stuff, that you have good talent in-house, and this helps to attract other people. And in general, these software frameworks really help spread AI adoption, which then helps your entire ecosystem. So the geopolitical implications, we could maybe say, of these software frameworks are more indirect, but nevertheless, these are important. For example, the Chinese government is thinking really strategically about AI frameworks and its domestic open source ecosystem. It has invested in a domestic alternative to the code hosting platform GitHub, and also recently a think tank under the Chinese Ministry of Industry and Information Technology has published a white paper on a specific question of these AI frameworks and their role. The last key ingredient is talent. So experienced AI researchers are still in low supply. So getting the brightest minds to your company or to your country plays a really important role in AI. With regards to talent, we can observe two types of brain drain, basically. On the one hand, there's a lot of talent flowing from academia to industry because especially big tech companies can offer enormous salaries, which nobody else can basically compete with, even the poshest US universities. But then there's also a lot of brain drain between countries. For example, the US exerting a strong pull effect in general in AI. According to an estimate published by a US think tank CSET, approximately 80% of PhD graduates in AI stay in the country long term, even though 2/3 come from abroad. So the US attracts a lot of talent from abroad, and then this talent stays in the country. Overall, geopolitically, strategies to educate, attract, and retain talent play a very important role. This can be seen, for example, by the Chinese efforts in this with regards to talent. On the website China Talent Tracker, also published by the US think tank CSET, you can find a catalog of Chinese party state-sponsored initiatives aimed at cultivating China's domestic talent pool in support of China's strategic, civilian, and military goals. And many of these initiatives are targeted specifically at AI talent. So in conclusion, I hope my presentation gave you a good overview of what AI actually means today, what we really have already when we talk about cutting edge commercial systems that are deployed at scale. And I hope that I have showed you that the geopolitical competition in AI doesn't start at the level of application. So it doesn't start, for example, with facial recognition or autonomous driving, but way earlier. It starts already at the level of data, compute, software, and talent. Therefore, access to and control over these key ingredients really will determine how states can leverage AI for their economic, political, and military power. And as I hope to have shown you, only a few actors worldwide have all the ingredients to build and deploy large AI systems at scale. And in the future, this will lead to new vectors of dependencies between countries, but also within countries. This is the end of my presentation. Okay. I don't have an overview of the time.
No,
I hope I didn't take too long.
You're on time, thank you. Okay, thank you so much for the presentation. We're going to move to our second session about the Q&A. I'm going to encourage all the audience to post your question in the Q&A menu below, but maybe I'm going to start with the first question for you. AI is still considered as a Western concept, so how do you think that this kind of myth that AI is only dominated by the big player from Western countries, to extent this will discouraging many countries from the global South to compete or to participate in the AI?
That's a very good question. I hope my presentation didn't give the impression that it's only Western companies that currently dominate the AI space. So there are also really strong Chinese players in the sector. For example, we might think of TikTok with the international app by Chinese company ByteDance, and ByteDance also has the domestic, not alternative, but the domestic counterpart of this app is Douyin. So together, TikTok and Douyin have are really powerful apps and are among the top social media apps, and they for example employ very sophisticated AI algorithms which have really mastered keeping people addicted to their apps and increasing the time people spend on these apps. So this is only one example, and of course it's a big issue that AI is currently dominated by, we can describe it a bit as a duopoly of Chinese and US companies. But I think, and that's certainly a problem, and new global dependencies will arise from that. But I think because you especially asked, I think you asked what countries in the global South can do. I think it's often underestimated what role the collection of data in your specific location plays. So, for example, in autonomous driving, or in general in AI, it's not possible to export these systems simply to other countries and expect that they will work the same way as they do, for example, in the US, because you have different cultures in autonomous driving. People have different ways of navigating traffic in other countries, so you need different data sets. And I think this is where some of the opportunities also of countries in the global South lies. So really knowing their own cultures, really knowing what are the specifics, the characteristics of your own domestic culture and ecosystem, and then trying to build solutions really targeted to that.
Okay, so there's another question from the audience. Will AI have a huge impact on the climate crisis or the air pollution issue? Because you haven't mentioned about the cost. Because if we need a supercomputer to perform a model from AI, it will consuming a lot of energy. Can you elaborate more about the impact to the environment?
Yeah, totally. Unfortunately, I didn't have so much time in my presentation, so I had to cut a lot of aspects in the end. But of course, the implications, especially of these large-scale models when it comes to carbon emissions, are immense. And these models, just training them requires a lot of energy. And this also and it's also, as I said, the costs sometimes go into the millions. So once you've trained such a model, it's also difficult or sometimes not feasible to change them afterwards. So because it's simply so expensive to train them. So once you notice a thing that could be improved in your algorithm and you've already trained the model and put all this energy and money into it, then yeah, it's not so easy to change afterwards. So there's some sort of solidification, and yeah, it's difficult in that sense. It's difficult to change these systems in the end. And of course, I think climate change is an interesting example, because when it comes to climate change, there's also a lot of hope with regards to AI. So people hope that AI can significantly improve climate modeling and thereby help combating climate change, or that AI can help people lower the amount of energy they use, for example, in their homes by employing Internet of Things techniques and systems. So there's really this, so I don't have an answer to this, like a concrete answer to these questions, but there are always these two sides of the equation, and we need to yeah, look at both. But I think definitely with these large-scale models, the environmental aspects are something that is definitely not considered often enough. And you may have heard of this case from Timnit Gebru, who was in Google's AI ethics teams, and she was fired over publishing a critical paper on these large-scale models, and specifically also pointed to their huge implication with regards to the environment. And she left Google, or she was fired or had to go. And this example, I think, shows really well that these big tech companies currently dominate a lot of the discourse also that we have around AI, and at the same time they are able to silence critical voices, and that's really a problem. And I think we need to, as a society, focus more also on these critical aspects if we want to harness the benefits of AI for the social good.
Okay, there's another one. Between two major powers, what role will global South countries like Indonesia will play in this AI geopolitics future? Is global South going to continue to be at the bottom line of the supply chain, or else?
Yeah, I think that's a very good question. And of course, that's one of the questions that first come to mind when thinking about the geopolitical implications of AI. I tried to give you some more hopeful answers in my last reply, but I think when it comes to this question, I think we can really expect a rise in inequality, because AI is currently dominated by these large big tech companies, and if AI is really going to spread out to different economic sectors, and more also smaller companies will employ AI for their own purposes, then there's really this problem that they are dependent on the infrastructure of these big tech companies who provide AI as part of their corporate cloud solutions. So you can use their cloud solutions to train models, because you don't have the infrastructure in-house. You don't have a supercomputer in-house, obviously. And so these clouds, you can rent such a supercomputer and pay these companies rents. That will lead to inequality already, but then also they equip their cloud ecosystems with also pre-built models. They make AI as simple as drag and drop, or at least that's what they try to do, so that many people are attracted to their ecosystems. And I think because they make it so easy, there will be an increase in the power of these big tech companies. I also mentioned this example of Google's Colab, which is this website that you can just visit, then write and execute some code on Google's machines. These are all ways of really spreading the use of their hardware in the world and in the wider economy. And if AI is really going to develop, as many people predict, as a general purpose technology and will enter all these different economic sectors, then I think this will only solidify the power of big tech corporations, unfortunately. And yeah, that's where we also need to pay critical attention to.
I have a personal question for you. To what extent the role of the state regulation in cooling down or maybe even provoking the tension between the big players in AI?
Yeah, I think state regulations and also incentives play a very important role in AI. So currently in Europe, there's a lot of attention on the AI Act, which is the first attempt globally to regulate AI applications. And yeah, it's Europe's attempt to really control that the AI applications we end up with are aligned with Europe's values, more or less. And there are still loopholes in the current draft. Is currently being negotiated, and there's a lot of discussion around that. But when it comes to these geopolitical questions, it's not only the laws that regulate how AI is being used, but it's also a wide spectrum of other regulations that are important in this context. And for example, think about efforts to strengthen the domestic semiconductor supply chains. The EU has just published a draft for European Chips Act. The US has its own Chips Act. So this is an important area. Then there are also, as I mentioned in my presentation, for example, initiatives to attract talent. Data laws and regulations are really important when it comes to regulating how data is used, how we can incentivize players in our societies to share data more openly. How does this go in hand with privacy concerns? So data protection laws obviously also play an important role. So I think when it comes to AI regulation, we can't just look at this application layer, but as I tried to do in my presentation, we also have to consider the different underlying infrastructures and these 4 key ingredients. And yeah, this is also what many states have realized and are now increasingly trying to do. So creating laws and incentives to strategically make use of their current ecosystem, really understand the technological ecosystem and how they can best promote targeted efforts to improve it.
Okay, still connected to the question about the regulation. With the trend of rising digital authoritarianism among Asian countries like Indonesia or maybe the Philippines, Myanmar, do you think that state being the regulator on AI will be sufficient for Asian context? Because laws tend to be exercised for the advantage of the ruler.
Yeah, that's a very good question, and there's this huge discussion around the question whether AI will ultimately be a tool for autocratic regimes to solidify their power, for example, through systems for facial recognition, for speech recognition, things like the social credit system in China. So there's the question whether, on the one hand, AI benefits from these autocratic states, as I tried to explain at the example of the facial recognition industry in China, which really benefits from this governmental push to these systems. And then also the question whether autocratic regimes will benefit from AI, because AI allows for applications, like facial recognition, for example, which allow them to really monitor their societies, survey people on a large scale, and this there's also already some empirical evidence that this really helps evidently to prevent protests. And
Okay, there's another one. Do you think AI gaining conscience, as seen as in a lot of science fiction movies, is something realistic in the near future?
I kind of expected this question, but as I also tried to briefly mention in my presentation, all this discourse around strong AI or artificial general intelligence, or you may have heard of the term the singularity. These are all very distant scenarios, and I'm also very skeptical about this kind of discourse, because I think it also is often this is marketing talk, which really helps accelerate the hype that has developed around AI. So I'm really skeptical and critical of that. And then also personally, I don't think this will be anything that we have to deal with in the near future. So in order to reach something closer to human level intelligence in AI, we would need several other research breakthroughs, and these don't come up every couple of years, but it's more, it will take much longer, if at all, we reach such human level intelligence.
Another question will be related to the citizen. How do you think that ordinary citizen like me will be aware about the impact of the AI and datafication in our everyday life?
That's a good question. I mean, AI already affects people in their day-to-day lives. And although I think many people are not aware of the implications and don't necessarily are not necessarily very critical about it. I recently, this comes to my mind right now, I recently read about this example from Munich, where an AI startup from Israel is doing sort of a test project, and they are implementing AI surveillance cameras in the public swimming pool in order to help the people watching the swimming pool prevent more people from drowning. And in Germany, people don't really drown a lot in pools. The numbers are really low, but nevertheless, the swimming pool in Munich has decided to do this test project with this Israeli startup. And I think people don't really realize that with these kind of systems, you always have to balance the benefits and the costs. And I mean, the costs in this example are very high. I think not many people would want to be surveyed when they go to the swimming pool in their swimwear, and then also especially considering the bad cybersecurity that such surveillance systems sometimes have. So especially if these the software systems are not up to date, such systems could pose massive dangers and infringe people's privacy. For example, if the systems are hacked and the images of the surveillance footage end up on the internet. So I think, from what I observe, AI is often seen as a good solution to almost any problem. And what we really need to do more is ask, do we really need these systems? And are there other ways, and are the dangers of employing them maybe too high? Can we find alternative solutions that don't infringe people's privacy that much, for example? And that would be my answer.
It's okay. Have you also noticed, is there any global regulatory framework that can be applied to the AI practice in various countries, for example, not in a specific country?
Sorry, I'm not sure whether I...
Is there any global regulatory framework that can be applied to many practices of AI in different parts of the world?
So there isn't a global framework yet. And this attempt by the EU is really the first attempt to create a law that regulates how we use AI and what AI applications we want and permit and which ones we don't.
And also, are you familiar with some kind of movement from the civil society for demanding that AI practice needs to be more ethical, or maybe the process of datafication need to be considering the idea of data justice? Because from my own experience, this kind of movement tend to be started from many social movement in Europe. Can you share your idea about that?
Yeah, of course. Especially in Germany, there are many civil society organizations that are worrying, that are worried about the developments in AI. And also we have organizations that connect civil society organizations from various European countries and create a discourse, a critical discourse at European level. For example, there's European Digital Rights, which is a very well-known organization in this space. So we have many, luckily, and this is also something that gives me hope, many civil society organizations who really do a lot of also research and create evidence and collect data about, for example, in Germany, we have Algorithm Watch, and that's an organization that does a lot of also foundational work. So they collect a lot of evidence about algorithmic systems that are applied in different contexts and lead to discriminatory outcomes, for example. And this work is really important. And yeah, so this is something that makes me hopeful.
Okay, so if I want to be a person that can advocate my peers, my family, or my colleague at my office about the important role of AI, the bad side or the positive side of AI, where shall I start?
I think it's always important when this argument comes up. I have nothing to hide. It doesn't matter if these companies collect my data, because that's simply not true. There are many things at stake, and data collection shouldn't be a business model of big companies. And yeah, we really need to keep an eye on other systems and really decide consciously which systems we want in our daily lives. For example, do we place a voice, like an intelligent smart speaker in our bedroom or not? I think these are discussions. So whenever someone in your family buys such a device, I think this is what I do. I try at least to make them think about the implications of this, especially when we look to autocratic regimes. So especially when we see in China, for example, in Xinjiang, that there are voice recognition systems also used to identify people from the Uyghur minority and oppress people. The same holds true for facial recognition systems in this particular region of China. So many of the use cases even if these systems are often fun and of course they make our lives much more efficient and are really helpful, we need to keep those negative implications these systems could possibly have in mind. And this is something I think everyone can do in their day-to-day lives to really keep the discussion going about the potential dangers and risks.
There's an increasing issue about data protection in Indonesia, because during the pandemic, when the government tend to utilize data for the surveillance in terms of managing the pandemic, but there's also increasing sense of distrust among the Indonesian public to the government in how the government manages the data. So, for example, they might be afraid that the data they collect during the pandemic will be sold to the third party or maybe sold to another country, for example. Do you have any commentary regarding this issue?
Yeah, I would say I definitely understand such concerns. I mean, data, a lot of data about people, that is, especially if it's hosted in a central database, that's always something that should make our alarm bells ringing because it's difficult to protect such a central database, and even if we have it, even if it was originally for socially beneficial purpose, such data can always be misused. And before such data collection from governments is put in place, I think it's always important to make sure that there are really rules that really define who can use these systems, what can be done with them, what shouldn't be done with them under any circumstances, and how can we protect that this data isn't, that these databases aren't hacked, for example, and the data ends up in places where we don't want it.
Okay, one final question from the audience. Hi, thanks for the talk. I'm just curious, do you have any recommended readings if you wanted to delve deeper into the topics of AI, economics, and geopolitics? I really like your discussion on how very tiny little things like microchips and semiconductor is affecting the geopolitics. So do you have any recommended readings for this?
Yes, definitely. I think I could provide you with a much better list if you would simply drop me an email, because then I have all my readings in front of me and I could make sure that I don't forget anything. Okay. Yeah, so just drop me an email. I think what comes to mind directly is the work of Nick Cernak, who does very interesting work on the implications of the rising compute requirements in digital capitalism. I also think of Virginia Eubanks, who has done really important work on the use of algorithmic systems in various contexts in US society, and she really shows very clearly how these systems are often disproportionately affecting historically marginalized communities. So I think that's one of the foundational readings I would always recommend. And yeah, if you drop me an email, I will send you a list specifically on the question of semiconductors and AI.
Okay, thank you so much. Since we're closing in time, do you have any final remarks for the audience regarding your discussion for today?
No, I don't think so. I really enjoyed it. Thank you again for inviting me. And to anyone, if any other questions come up, feel free to approach me also after the presentation. I put my email address on the slides, so once it's uploaded, feel free to reach out, and maybe we can have a chat afterwards.
Okay, thank you so much. Thank you for joining us for this session in this late afternoon. Our last session, Future Imaginaries, will start in 1 hour. It features Stephen Oram, who is a science fiction writer. We'll talk about the role of science fiction in imagining the future. So see you around in 1 hour. And thank you so much, Wiebke, for your time in sharing the knowledge to us. See you next time in another session then. Thank you so much.
Thank you so much for moderating and for having me. Bye.
Thank you. Bye.